So now we are starting with the next topic, that is origin and evolution of Earth. Now this topic is very much vital, specifically in order to get a clarity, in order to get a proper understanding that how our Earth and how our solar system would have been originated. So we're going to see about some sort of theories. Now one thing I want to mention here is that though geography is logical, there are logics, and it is very much, you can say, near to the science. However, logics will not going to apply it universally, so we always have an exception in geography. That is the first thing. Second thing is, like, when we are about to discuss these theories, and in these theories you will see that there is some sort of physics involved. So I would like to say here that you just have to be clarity about the general understanding of physics, not the expert kind of base, not the detailed physicians or let's say physicist opinion. You have to be a journalist. You have to be a generalist idea, general. Okay, this general, not J. You must have what? This idea. Sorry. Must have this idea. General idea. There is no need of expert ideas as far as the origin and evolution of Earth. I mean, as I told you that some sort of physics is involved here. You just have to be take care about the process itself. Need not to deep dive in the terms and need not to find out about those terms, because this topic is low weightage. Still, the things are developing with respect to the origin and evolution of our Earth. So if UPSC would going to ask question, believe me, those questions would going to be covered in that in today's lecture itself. However, if you see some sort of differentiation, you can go with some sort of standard books as well. However, the content which is there and the content which you are about to see in class would be by and large same. So I would say to stick this PPT, or especially the theories which we are about to deal, which we are about to discuss. Otherwise, you might drift from geography to physics. So you should be with the physics. Sorry, you should be with the geography, not with physics. All right. So with this assumption, I hope you will take these theories in a journalist manner. Now, regarding the origin of our Earth and our space, there has been so many theories which has been given by philosophers. Sometimes Emmanuel Kant, you will study about the teachings of Emmanuel Kant, especially in paper 4 ethics. So that Emmanuel Kant, who is, you can say, the person involving here as well. We have a Laplace mathematicians. So we have a scientist as well to explain the Big Bang theory as well. So all I want to say here is that the theories which are related to the origin of our Earth and our space, theories were actually given by scientists, philosophers, and even the journalist, we can say, teachers as well, or journalist people, we can say. Theories were actually given. Now these theories, the theories which were given, the theories which were provided, now all of these theories can be categorized in two ways. We have a categorization in two ways. First, we have a early theories, and then we have a modern theory. Early theories and modern theories. Early theories, if you see, so early theories are basically the theories which were based on the limitation, specifically when we have some sort of limitation of knowledge during the respective time period. So we have a gaseous hypothesis of Kant, which further refined by Laplace, and that becomes Nebular hypothesis of Laplace. Then we have a Chamberlain and Boulton's wandering star or planetesimal theory, which further refined by Jean and Jeffrey's tidal theory, which further refined by Russell's binary star hypothesis. So there is, like not much variation, especially in these theories, but one theory was actually become a background for the next successive theory. So here we have this group of theories, here we have this group of theories, then we have a completely different theory which basically become the base for modern Big Bang theory, that is the Schmidt's interstellar hypothesis. And then we have a modern theory which is based on the observation, which is based on empirical evidences, which is based on universal kind of application of science. So as of now, we have one of the most relevant theory, that is the Big Bang theory. However, equally there is an importance of Nebular hypothesis and these respective theories as well, though these theories have some sort of limitations as well. So we are about to discuss all these theories in a detailed manner. So when we are studying about theories are always based on assumption. There are some assumption, and based on those assumptions the theories are actually stands. If the assumptions are wrong, theories will be automatically. So here we have some sort of assumptions. With the assumptions, theory will be relevant, theory will be validated. Yes, you might see that the assumption which has been taken in the theory, there might be a lack of clarity, there might be a inadequate explanation of those assumptions, but that's why it is theory. Okay, it is not what a kind of application, it is just a theory. All right, so we are beginning with the very first gaseous, and this gaseous later being known as nebula. So we have a gaseous hypothesis by Immanuel Kant, which later added and becomes what? Nebular hypothesis by Immanuel Kant. So as per this Immanuel Kant, he first of all took one assumption. And what was that assumption? That there is a primordial cloud of gas. There is primordial cloud of gas, and this primordial cloud of gas was actually being referred as what? Nebula later. So first of all, like whatever solar system we see, the earth which we see, all of these are actually the remains of this particular nebula or this primordial cloud of gas. So solar system begins through, like, it was commenced due to this huge cold cloud of gas, and this nebula, here you can say cloud for example. So this cloud was cold, this cloud was comprised of some sort of gases, this cloud was comprised of some sort of fine particles as well, and they were actually scattered in that particular, we can say, nebula or the cloud. So there is a one cloud, in that cloud we have like a cold conditions, we have a gases, and we have a fine particles. This is what the assumption in this particular theory. Now if you ask me from where this nebula comes, there is no explanation. Okay, so this is what the assumption in this particular theory. Moving ahead, so here if you see, like, hydrogen was there, here if you see in this particular cloud, helium was also there, and the dust particles or the cosmic dust was also there. As a result of this small dust particles or cosmic particles, gradually what happens, that there was a gravitational contraction. Gravitational contraction was started. So when we have this gas cloud, so this gas cloud started to contract. It started to contract because the fine particles which were there, they have some sort of affinity to have a accretion, means they were actually becoming closer due to their own gravity, and when they become closer due to their own gravity, this actually resulted into the contraction of this nebula, and this nebula started what? Shrinking. And as it further shrink, there was a further contraction, and as a result of further contraction, what happened, that the density and the temperature was actually increased. The density and the temperature at the center was increased further. It's because of the dust which is there, it's because of the gases, it's because of the, you can say, cosmic dust which is there. So as a result of this, what we have, what we have, like the gravity, due to the gravity of those dust particles, this nebula started to contract, and as it started to contract, while following the conservation of angular momentum, there is one angular momentum, especially in physics, need not to deep dive, you just have to take a reference that it's because of the angular momentum. Now this cloud which was actually shrinking, which was actually contracted or contracting, now that started to spin, that started to what? Spin. So here this particular cloud has contracted, and as a result of the contraction, it becomes narrower, it becomes less broader, and it started to what? Spin. It started to rotate, you can say. Now rotating mass flattened into a disc shape. Further the rotation was there, and as a rotation, ultimately we have what? This disc shape. So this disc shape was actually being observed, especially as a result of this process. Most of the mass here, if you see, most of the mass was actually pulled towards the center. It's because of the centrifugal force and the opposing gravitational force. If there is a balance, so accordingly we will have an equivalence. So most of the mass got pulled towards the center. Most of the mass. Center becomes more and more denser. Center becomes more and more hotter as well. It's because the density is actually increasing, or the density was actually greater. So this concentrated central mass led to the formation of protosun. Protosun means prior to the fusion, or you can say protosun means the sun which is not having some sort of nuclear fusion. Sun which is having a idle stage, where the sun is not emitting the light. So that is the condition of what? Protosun. It's just like Earth. It is about to fuse, it is about to start, it is about to release, we can say it is about to emit the heat. So here we have contraction first. Due to the contraction, there was what? Conservation of angular momentum. In order to follow that, disc shape was there. Due to the disc shape, further the density or temperature was actually increased at the center. As a result of this, what happened? The center mass was formed, and that is being known as what? Protosun. So protosun was actually being formed. Till now, protosun means the prior stage of fusion sun. So continuous contraction was there, and as a result of continuous contraction, at the center part, the temperature becomes critical, because at the center parts the gravity was more. Due to the gravity, the friction among the particles were more. Due to that, the density was more. Due to the density, temperature was more, and due to that temperature, as the temperature was increasing continuously, the increased temperature resulted into the reaching up the threshold limit, and when that threshold limit of temperature was breached, as a result of this, hydrogen fusion began in that protosun, and now that is being called as what? Sun, the youthful sun, which is actually emitting light. So when we have a protosun, this protosun was further contracted, it was further get dense, it further get hotter, and hydrogen atoms, hydrogen nuclei were already there. So temperature becomes what? Beyond the threshold level, fusion was started. Protosun, idle sun becomes sun, means youthful sun, you can say, or let's say the sun which is actually emitting the lights, that was came into the existence. In the outer region of disk, in the outer region of disk, so let's say here we have a formation of uh, like a sun. Let's say here we have a sun, protosun, and then we have a sun, for example. During that point, that time period, when the sun was there, especially during this time period when the outer regions of that disk was there, so in the outer part of that disk, now this is about this, the sun is all about the central part of that disk. On the outer part of that disk, what happened, that the matter clumped together by the collision and the accretion. Accretion means when there is a collision but the particles have a tendency to remain closely with each other. Okay, so there is a what we can say collision, but due to the collision the particles will remain close, they will not going to move away. So due to that accretion, the planetesimals were actually formed, means the dust was actually resulted into the small lumps, small bodies of planetesimals, which later being known as planet. Now this activity is actually taking place on the outer part of that disk or outer part of that ring. So in the inner part sun, on the outer part the planetesimals were actually being formed. Moving ahead, over the time these planetesimals, which ultimately small lumps which were there as a result of their own gravity, the planets were actually being formed, and these planets were become cool, and as a result of their cool surface, the solid crust was actually formed along with the early atmosphere. So this is how we have what the formation of our solar system, our earth or the sun. Now this theory have some sort of limitation. Okay, like though it is sequential, though it is logical, but it is also having some sort of limitations. What limitations are there? Now this theory is actually not having a scientific evidence. Unlike Big Bang theory, I'll tell you that recently we have launched a James Webb telescope in space. Now from that James Webb telescope, it has been deciphered that our universe is actually expanding, and that Big Bang theory is saying the same thing, that the universe is expanding. So there we have a scientific evidence, but with this particular theory there is a lack of scientific evidence. There is just a connecting dots without logics, because the earth's surface is solid, so we used to say that this contracted and then we have a dust particles, accretion, and the planets were formed, so that it's looked like a match. But theories should be supported by evidences. So here there is a lack of scientific evidence. Now there is an inadequate explanation of the heat source. So as like on the central part, like a protosun which was formed, and later it becomes what a youthful sun, or let's say the usual sun which we are seeing nowadays. So how that was happened, that process was not adequately explained by this particular theory. Distribution of angular momentum, in physics it is somewhat different, but when you see the disk shape which is having a some sort of large variation, it is very difficult to justify the distribution of angular momentum. So this is also one of the limitation of this particular theory. Planets cooled, so this cooling assumption is also not we can say well explained by this particular theory, and this particular theory also ignored the external forces. This particular theory ignored the solar flare. This particular theory ignored the gravitational pull of one or another planet. This particular theory also ignored the magnetic field of the planets, or let's say sun. So they were not covered to justify this. However, this theory has some sort of credibility in terms of the earth crust, because it is solid and the end result is also solid. We have a fusion on sun, so this theory is also explaining that it's because of the hydrogen, it's because of the helium atoms, the sun or protosun become ignite and it becomes sun, which we used to see nowadays. So this is the particular theory of Emmanuel Kant Gaseous Hypothesis. Here you can see, so this actually began around 4.6 billion years. This is what the crux, I would say. So it was began during that point of time. Then the cloud was smaller part of this particular nebula, we used to say. Then there was a flattening disk. Then the fusion occurred. Then we have a like a material in this way, and we have a existence of our solar system in the modern way in this particular sequence. So that is all about this gaseous hypothesis by Kant, or let's say nebular hypothesis by Kant. Now, this hypothesis has its own limitation, and because of the limitation, this theory was not credible, not that much credible. However, during the time period when this theory was actually advocated somewhere in last century, so during that point of time, the limited knowledge was there, limited technology was there. So this theory to some extent provide a way forward to scientists to go or to find out the various other theories which could be related or which could justify the existence of our solar system, including Earth. So that theory actually work as a foundational blocks, though not relevant, but give a direction regarding the origin of our solar system and our Earth. So Laplace nebular hypothesis. Now this Laplace nebular hypothesis we're going to see in a next session. Till then, take care.